Alright, so now we're going to dive into the meat and potatoes of what really 6.5 is about, is anti-differentiating, the real calculus side of things of partial fractions. So we have a starting example here in which we're going to integrate 3x to the fourth plus 1 divided by x squared minus 1. What's the first thing that we notice here, guys? Think about it. What's the first thing that you notice about this particular fraction that is set on up and we're thinking about partial fraction decomposition? Hopefully you're starting to realize, well, last time I checked, the denominator is supposed to have a degree that is less than our numerator. That's not happening here. We're seeing it's x squared and x to the fourth. So we have to, in turn, get this to a spot to where we can actually go ahead and find out something about this being a partial fraction decomposition. And remember way back when we looked into how do we divide polynomials using long division? Well, now it's coming back into play. We're going to have to use some long division of polynomials to go ahead and find this in a way where I can actually find what the quotient is and the remainder as well. So let's go ahead first and find out what the quotient and the remainder are going to be. So we need to divide x squared minus 1 into our 3x to the fourth. I'm going to put the plus 1 out here just because we got to make sure that we keep in mind our plus 0x cubed plus 0x squared plus 0x that's in there as well. Alright, now let's keep moving along. So x squared goes into 3x to the fourth. That would be 3x squared times. Multiplying down, you get 3x to the fourth there, as you should, and it'll kind of cancel along with it. Alright? 3x squared times the negative 1 gives us a negative 3x squared here as well. So now we're just going to cancel on out. Well, that 3x to the fourth will cancel on out. Remember, this is subtraction that really happens in here, so that will cancel. This becomes a positive 3x squared now. Now, once again, we have to ask ourselves, well, how many times x squared divide into 3x squared? Well, that's going to be a positive 3 times. And then 3 times x squared will give you 3x squared. Once again, this will subtract on out. 3 times that negative, 3 times that negative 3 in there will end up giving the sorry for that, guys. Someone came into my classroom. So now we're looking at here. We want to bring down our positive 1 because now we're down to our end here. So we want to add that plus 1. And 3 times our negative 1 will give us a negative 3 in this example. So then 1 minus a negative 3 will give us a positive 4 in the end. All right? And so now we've actually found out what the degree and the actual remainder, excuse me, not the degree, the quotient and the remainder is in this example here. And you'll see how it kind of helps us on out as we continue to push a little bit farther. So I'm going to go ahead and erase this now. And then we're going to rewrite this, guys. All right? Because this is the same thing now as the integral of 3x squared plus 3 plus our remainder over our denominator. That's just going back into our long division pre-calc algebra 2 days there. Well, now we're getting to be a little bit more possible in what our options are here. Well, look what happens. If I separate this out, I have the integral of 3x squared plus 3. Super simple to go ahead and to find that out. Plus the integral of 4 over x squared minus 1. Well, this ends up just being x cubed plus 3x. And now here is our partial fraction decomposition. So remember what our goal is. Our goal is to separate this on out. Well, we all agree this is the same thing as x plus 1 times x minus 1. Well, there is our two linear factors that we can work with. Now, these two linear factors that we can deal with in this case, x minus 1 and x plus 1, we need to go ahead and find out what the values of a and b are going to be. Let me change colors here and put a little side note in. I want to go ahead now and find specifically that this is the same thing as a over x plus 1 plus b over x minus 1. And so, just like it was before, a times x minus 1 plus b times x plus 1 over x plus 1 times x minus 1. This gives us the opportunity that the numerator is now equal to the numerator that it was before in 4. And so, we can take a times x minus 1 plus b times x plus 1 is equal to 4. Alright, so now we got to think to ourselves once again. We want to cancel out one of them and leave the other. So a positive 1 would cancel out a, and a negative 1 would cancel out b. Okay? So it doesn't really matter which one you want to look into first. Let's go ahead and let's cancel on out our first one here in b, I guess. So let's go ahead and look at this one. So let's go ahead and say, hey, a times a negative 1 minus 1 plus b times negative 1 plus 1, in this case we'll cancel on out, and that will equal 4. And so we have a negative 2 times a is equal to 4. So a will equal a negative 2 in this example. And then b, we'll do just the squiggles over here, kind of separate it out a little bit. Same thing, we'll make it 1. So now let x equal 1. And so a times 1 minus 1 plus b times 1 plus 1 is going to equal 4. And so then 2 times b will equal 4, or b will equal 2 in the end. And so now we have gone ahead and found out that we can write this as a partial fraction decomposition. So once again, I'm going to change colors and move on over to the left-hand side here. And now I want to put it on over into what we're looking at. And I'm going to keep some things a little bit nicer and clean. So we already have x cubed plus 3x. And then now we have plus our integral of 2 over x minus 1, and then plus the negative 2 over x plus 1, all still times dx. Well, now think about what we have here, guys. A constant over x minus 1, a constant over x plus 1. The integral of 2 over x minus 1 is just 2 times the natural log of x minus 1. Negative 2 times the natural log of x plus 1. And so now, when this is all said and done, our integral is x cubed plus 3x plus 2 times the natural log of absolute value x minus 1 minus 2 times natural log x plus 1. And then don't forget your plus c in there as well. You may see this at some point, guys. You may see this as just a simplified version of it, because this is a negative, remember. This is quote-unquote the division of 2 logs. So you may see this being written as well, too. So remember, just be on the lookout for when we simplify it down using our logs as well. Alright, so real good example to start our partial decompositions of an anti-differentiating kind of all mixed together. It is a pretty extensive one. All right, so let's go ahead and give one a shot on your own. The one I want you guys to look into is to go ahead and integrate 2x cubed over x squared minus 4 dx. And when this is all said and done, in the end, hopefully we see x squared plus natural log x squared minus 4 all to the 4th power plus c. Alright, and you might get a little bit of a different answer in there depending on if you actually condense the logs and things of the nature. But test yourself, see if you guys can make sure that you are remembering some of those log formulas as well. Alright, and we're on to the next one, folks.